Good morning, 8th grade class. I hope you guys are having a good time. Mr. Hale here. Today we're going to start talking about our next chapter. Our next chapter is called Characteristics of Waves. Today's lesson is going to be about what waves really are. First, we have to understand that there are different types of waves. We have two main types. You got mechanical waves, the ones we're going to talk about today, which require a substance to move through. And then you have electromagnetic waves, which don't require, like light and microwaves and infrared. We're mainly going to focus on these, the mechanical waves. There are two types we'll talk about in a few seconds, transverse waves and longitudinal waves. First, a wave. A wave must have something to move in, especially the mechanical waves we're talking about. Okay, the material through which the wave travels is called a medium. Okay, that's a medium, which we sometimes call it media. Okay, that's the substance in which the wave is traveling. Mechanical waves are waves that need a medium, like water and sound waves. And electromagnetic waves do not. They're like your light waves. What causes a wave? This happens in all aspects. Waves have got to be caused by something. And since waves transmit energy, a big key concept, you need to know that. Waves transmit energy only. They do not transmit particles, they transmit energy. Thus, to create a wave, you have to add energy to create that wave. Here, to create an ocean waves are going to be created by blowing over the water. The wind is creating and adding energy to the water, and thus the water starts to vibrate and creates a wave. Ocean waves are going to be affected by a few different things. The speed of it, how fast the energy is coming in, the duration, how long the energy is being added, the fetch, the distance over it, and the amplitude, how much energy is being added to it, is going to create the different styles of waves that we see. Now, there are two types of waves, really three types of waves. You have transverse waves. Here the particles move perpendicular to the direction of the wave. The wave is moving, the energy moves through the particles vibrate as the energy hits them, but the particles stay in the same spot. They don't move, they just vibrate. They don't move with the wave, they vibrate as the energy passes through. Think of it as a baseball game. You have the wave going across in the stands, and people stand up and they sit down. As the energy hits you, you stand up, you sit back down, and the energy passes you. That's a transverse wave. You've moved perpendicular to the motion of the travel. The wave's moving left and right, you're moving up and down to do it. Another style of wave is called a longitudinal wave, where the particles kind of compress and relax. It's like a slinky, holding a slinky, and you hit it, the slinky compresses and relaxes and compresses and relaxes. That's a longitudinal wave. And the other one's called a surface wave, a combination of the two, both longitudinal and transverse. We'll show you those in a little bit, but let's go look at some pictures of these particles. Here's a great picture of the transverse versus a longitudinal wave. Look at it closely. The transverse particles are vibrating up and down. Okay, the slinky's moving up and down. The energy's moving left and right. The longitudinal, the particles move parallel. You don't see the thing moving up and down. The particles move left and right. The energy moves left and right. That is a longitudinal. I'll show you another picture of a transverse. Here's a perfect idea of the transverse. Look at those red dots. They move up, they move down. The energy is moving left and right, but the transverse particles are moving up and down. They're moving perpendicular at right angles to the direction of travel of the wave. Now, here, let's look at this earthworm. This earthworm, if you look, is going to be more like which one? Is it going to be like the longitudinal wave or the transverse wave? Think about it. Is that motion a longitudinal motion or a transverse? Is that body moving parallel with the body's motion? And yes, it's a longitudinal wave. It's moving in line. It's not transverse. Here's some ideas of some longitudinal. Look at those red dots in the middle. Most people can understand transverse, but the red dots in the middle, as they vibrate back and forth, as the energy comes through, it compresses and relaxes. The red dots just vibrate. They vibrate as the energy hits, but don't really move in line, in direction with it. They just vibrate as it moves. Let's give you another picture of what that kind of looks like. Here's a better one that's looking at it. You got the bottom one, which shows you kind of a transverse wave, and the top one's your compression wave. The particles compress, the energy keeps moving through. until they get to the side. The particles, those red dots, kind of vibrate as it moves through. Okay, so those are, we'll get back to the main screen. Those are the three types of waves. Now the other one's called a surface wave, which is a combination of the other two, where the particles move in circles, left, right, and up and down. This normally happens in water waves. When a water wave hits you, you kind of get moved left, up, take to the top of the wave, you get pulled right, then down, you make these little circles. Those circles are called orbits. So, those are our basic topic for today. I hope you liked it. If you have any questions, make sure you ask during our Zoom sessions. So I'm going to sign out. This is KD2 LPM for K2GSG